Beep beep. Meep meep. Meep meep. Meep meep. Meep meep. Meep meep.
Alright, so why did we just watch a Rotor and Coyote cartoon in math class? So this is what I've always used to teach a certain math concept. And for now, I'm just going to call it the Coyote problem. It has to do a little bit with graphing, and it has to do with what we talked about last week about parts of a graph. But so as the story goes, you have a cliffside, there's the ground level, and a little catapult on top, right? And in the catapult, you've got your rock and your little coyote standing on top, okay? So when this launches, our coyote is going to be launched up, and then he's going to eventually splat, hit the ground, okay? And this is part of your notes, believe it or not. I don't expect you to have any artistic ability at all, but do your best to draw this as simple as you can. So he gets launched, woo, and ends up hitting the ground, right? Let's draw the rock down there. So when this happens, I want you to notice the shape. So this shape is sort of what we were talking about with a parabola. This is a parabola. It's a downward facing one. Notice it would go up and then down. It's that same shape that you see right here. So there's some questions we could answer here. Number one, what was his starting height? So let's call it the initial height. How tall was this cliff? We could figure that out. The pen isn't showing up too great. The initial height. I'm going to write that with a Sharpie. There you go, that's better. The initial height. How tall was this catapult up from the ground? How tall was this? The second question we could answer is, what was the maximum height he hit? So how high did that catapult launch him? At this tallest point, how high was he up? And then the last question we can ask is, how long did it take him to hit the ground? How long was he in the air? When did he hit the ground? So these are three kind of interesting questions we can actually answer through the power of math. How tall was this cliffside? How high did the catapult launch him? And when did he hit the ground? Pause it if you need to finish drawing this, and then we will continue. So here's the end of the notes today, believe it or not. There are four questions we can answer. What was the initial height? How tall was the cliff? What was the maximum height they hit? When did they hit maximum height? So how long did it take to hit that highest point? And then when did they hit the ground? How long did it take until splat? So for the initial height, this is going to be in a graph. This is going to be represented by c. In ax squared plus bx plus c, it's going to be represented as c, or your y-intercept. All right, so the initial height's going to come from the c value. So the number that doesn't have an x attached to it, that's going to give us the initial height. The second question, how do we find the maximum height? So for our vertex form, we had h and k, right? In the vertex, k gives us the maximum height. The k value is the maximum height. How do we figure out when we hit maximum height? Well, as luck would have it, in your vertex form, where you can find h and k, the h value is going to be when you hit the maximum height. So this will be the maximum height, and this will be when you hit it. Last question, how do you figure out when exactly you hit the ground? This would be found from the furthest right 0. And if you forgot, 0 means x-intercept. So when we do our graphing on Desmos, we're going to be looking for some things. We figured out how to find intercepts, right? When we just click on the graph, it shows us what the x-intercepts are, and it shows us what the vertex is. We can use those values to figure out how tall something was, how long it was in the air, what was the maximum height it took. But today is just notes. Tomorrow we will put this into practice. So now that these notes are in stone, tomorrow should be a piece of cake. So I hope you guys enjoyed the video. Have a great day.